Okay, here's the notes that will help you do assignment 2. So we're still working on polynomials. The date on these obviously can be different. It should be 2015. Okay, so this is polynomial still. The essential question here is what are the factor and remainder theorems? These are things you'll hear come up in Cambridge exams, the factor and the remainder theorems. They're theorems you use to justify your answers to things. And why are they useful? Okay, so I'm going to do the notes on these. These are also in your book in chapter 1, but let me talk about them for a minute. So the remainder theorem, top one here, the remainder theorem says that if you have a polynomial, p of x, and it's divided by some factor here, so x minus t, the remainder is going to be the polynomial evaluated at t. Okay? So I'll talk about why that's important here in a minute. Okay? The factor theorem says that if p of x is a polynomial, just like it was above, if x minus t is a factor, then p evaluated at t is going to equal 0. And then the second part is the converse of that. If p evaluated at t equals 0, then x minus t is a factor of the polynomial. All right, well, why is that helpful? Okay, let's work through an example here. All right, let's say the thing we're asked to do is to factor this polynomial completely. Okay, well, the only thing we've done so far in math is factor quadratics. We've never had to factor a cubic before. Let's hope that there are some factors of this that look something like x plus 3 or x plus 1, something like that. Okay? Now the first thing we're going to want to do is make a guess as to what things might be a factor here. Well, here's how we get our guesses. This last term here is negative 3. What things could I ultimately be multiplying together to get 3? Well, 3 and 1, right? So that's why I wrote over here, that's why I said, let's hope x plus 3 or x plus 1 is a factor. What are other good things to guess? X minus 1 and x minus 3. Because some combination of those should have to work in order for us to get this negative 3. Okay? Well, let's just go ahead and guess, or let's check to see whether x plus 3 goes in there. Okay? I'm going to have a little, so there's a different example in the notes here, but I want to step through one kind of with you. So I'm going to check this to see if x plus 3 is a factor of that. Okay? All right. Well, if x plus 3 is a factor of that, then the factor theorem says that when I plug negative 3 into here, that my function should equal 0. Okay? Well, another way to think of that is if negative 3 goes into here, and I can just do negative 3 synthetic. I can do synthetic division using negative 3, because if x plus 3 is a factor of this, then I should get a remainder of 0 when I use negative 3, because remember, the number that's here is the root of that factor. Okay? So what are my coefficients here? 1, negative 1, negative 5, negative 3. All right, when I plug that in, I get 1 times negative 3 is negative 3. Add those together, I get negative 4. Multiply those together, I get 12. Negative 5 plus 12 is 7. 7 times negative 3 is negative 21. That adds up to negative 24. Okay? So what does that tell me? That tells me that x plus 3 does not go into there because I got a remainder. Okay? So in this case, evaluated at t didn't work. Okay? And remember, because it's x minus t, that's why this was why I had to plug negative 3 in here. Well, let's check x minus 3. If x minus 3 goes in there, then when I synthetically divide in 3 to that same thing, I should get 0. Negative 1, negative 5, negative 3. Okay, good. Multiplying or adding down, I get 1, 3, 2, I get 6. That gives me 1. That gives me 3. That gives me 0. That's good. So what that means is that x minus 3 is a factor of that. What do I get when I factor that out? I get this as the coefficients with my exponents drop down. So here's what that means. That original expression that I had, x cubed minus x squared minus 5x minus 3 is equal to x plus, no, x minus 3, sorry. X minus 3. And when I take that out of there, I'm going to get this as my coefficients. So 1x squared plus 2x plus 1. Okay, so there's one part of factoring it. I found out what one factor is and I took it out. Well, now I'm down to a quadratic. So hopefully I can just backwards FOIL this into two other parentheses. So remember from factoring these down, x squared would have to be x and x in front. Oh, the only thing that adds up to, multiplies to 1 and adds up to 2 is 1 and 1. And since these are both positive, that has to be positive. Okay? Well, another way to write this might be x minus 3 times x plus 1 squared. Okay? And now notice, when I multiplied all these last terms together, I would get negative 3 times 1, which would be negative 3. And if I look back to my original thing here, my original expression, the last term was negative 3. So that should work out. Okay, on my notes here, I have a totally different example. Okay? This would be if I checked instead, if I started out by checking the x plus 1. Okay, now notice in the example I stepped through with you, we did x plus 3 and x minus 3, finding out that x minus 3 goes in there. Okay, but let's say I'd checked x plus 1. Well, that would mean I'd synthetically divide and use negative 1. And when I step through that, notice I got 0 as my remainder. So when the remainder is 0, that means t had to have been a constant. T in this case would be negative 1. All right, so in this case, when I factored out that x plus 1, what was I left with? Here's my coefficients. X squared minus 2x minus 3. Then I factored this quadratic down, right? So x plus 1 was a factor. This quadratic, I tried to factor down to two things at the end that multiplied up to negative 3 and added up to negative 2. Well, that would be negative 3 and positive 1. Now notice, here's the factors I get here, right? X plus 1 times x plus 1 times x minus 3. What were the factors I got when I did it the other way? X minus 3 times x plus 1 times x plus 1. Same factors, right? So this is really just a more complicated way of like when you broke down, when you did prime factors of 12, right? And you say, oh, 12 is 3 times 4. And 4 is 2 times 2. But you also could have gotten there by saying, oh, 12 was 6 times 2. Oh, and 6 is 2 times 3. All right, notice either way, when we're breaking this down into factors, we're getting 2 times 2 times 3. Same thing over here, 2 times 2 times 3. Okay, I think that's enough for you to be able to do assignment 1 and assignment 2, and that's everything that's involved in chapter 1. I grant you that's a lot of work, and we're going to spend a lot of time going over it when I get back. So hopefully this is enough so that you can get most of it done, work together, work well, and I'll answer questions when I get back.